Welcome. Thank you to the Energy Drone and Robotics Coalition for the invitation to speak before you today. We appreciate their support for the industry and certainly all of the technology that's being presented here this week. So my name is actually Jeff Leake. It's pronounced Lake. It looks like Leake. So a lot of people have said I probably should have changed my name back to Leake because it's so obviously important here. So we're going to talk about optical gas imaging and the future of gas leak detection. So I'm with a company called Sierra-Olympia Technologies. We're actually based in Hood River, Oregon. We're about 55 or 60 miles due east of Portland, Oregon, along the banks of the Columbia River. And we sit just below Mount Hood, and then at the Columbia River, especially at this time of the year, it's a very popular place to be because the river goes down and there's natural sandbars in that area, and it actually creates waves almost like the ocean does. And for that purpose, there is a reason to do windsurfing and kiteboarding. So the town will grow from about 15,000 people to about 50,000 people during the summertime. And then, of course, you have all the winter sports surrounding that. So it's a little technology hub. About 20 years ago, a company there started called In Situ. And In Situ developed a fixed wing unmanned aerial drone called the Scan Eagle. And that later, about 10 years later, was purchased by a company called Boeing. And the company In Situ, the president of In Situ and the person who started it, then started another company called Hood Technology. And I tell you that because Hood Technology is actually our parent company. We've been supplying mid-wave, long-wave camera cores, so thermal imaging camera cores, into the gimbals. So in the bottom left-hand corner right there, there's a Scan Eagle with what's called a rollover tilt gimbal with a series of different sensors. So since about 2010, we've probably delivered somewhere close to 4,000 or 5,000 mid-wave cooled sensors into this one program. And it's used for ISR, for surveillance and reconnaissance type applications. Has very, very long endurance. This has now kind of now been born into another product, which is called the Integrator. But we have a lot of experience for many, many years now working in drone platforms. So in addition to doing unmanned vehicle systems with our infrared camera cores, we also do persistent security and surveillance applications. These would be more for fixed mounted on poles or masts, that sort of thing, and for using very long range telephoto type lenses so that you would be able to observe targets at very great distances. And what we're going to talk about today is the utilization of a mid-wave camera core, and we developed an optical gas imaging camera out of that. So this is what we refer to as our Ventus optical gas imaging camera. And this is actually from a drone. This is an image from a drone over a tank battery. And one of the things that you're actually seeing is what's called a gas enhancement mode. That's actually colorizing basically the gas plume that is coming from the valve on the top of the tank there. So this particular drone you'll see downstairs. This is a product that's called the Matrice 300, and it's made by a company called DJI. And so typically you'll fly and you'll be able to visualize very quickly where the plume or the leak is. Then you can hover, and at the point of hovering you can turn on this gas enhancement mode, so it makes it very easy for the operator to be able to visualize basically again where the point source of the leak is coming from. So we're going to talk about some of the technology associated with the camera as it relates to detector materials, resolution, lenses, firmware and software, camera interfaces, and some application uses. So these are different examples of either using drones or using crewed, and when I mean crewed, not manned, we're using crewed now systems. In both cases, you can be able to use these from a wide variety of different aerial platforms. So our Ventus OGI introduced what's called, as referred to as VGA resolution, or 640 by 512. So comparatively speaking to the technology as it's been for about the last 20 years, referred to as quarter VGA, or 320 by 256 resolution, this particular camera now is about 4 times the resolution of the previous technology. The benefits of that is certainly the clarity and the sharpness of the image, and the ease at which you can be able to interpret what you're imaging and what you're seeing on the screen that you might be viewing. In addition, we went to a smaller pixel pitch. Previously, most of the sensors were using 25 micron pixel pitch, or 20, and so we've moved to this smaller 15 micron. Again, all of that to improve sensitivity. The next thing is the type of integrated Dewar cooler assembly. All of these cameras require them to be cooled. Previously, the material called indium antimonide, or INSBE, had to be cooled to 77 degrees Kelvin, or about minus 200 degrees centigrade. So a few years ago, in conjunction with the U.S. government, we started working with other materials so that we didn't have to cool the detector as low, and so we're now using what are called hot midwave infrared detectors. That means high operating temperature, and instead of 77 degrees Kelvin, they're now cooled to 150 degrees Kelvin. The benefit of that is we're able to improve cooler life. And previously, those other sensors were around 7,500 to 10,000 operating hours before the coolers then had to be serviced. And so now we're extended to 20,000 or more. The importance of that is for continuous monitoring applications, persistent continuous monitoring. So in our booth downstairs, you'll see 2 different versions of the camera. One of them is a very lightweight camera that weighs 542 grams. Again, it's a camera as a component. Notice the electronics and everything is exposed, because what our technology partners downstairs do is they take these and they integrate them either into a gimbal or into an enclosure or onto a pan and tilt positioner, and then they create a finished turnkey solution. So what you're going to see is the presence of this product at many of the booths in the hall that you'll be going into. So that cooler is super important in the midwave, that we get as long a life out of it as possible for these continuous monitoring applications. And so now we're offering one that goes even further for, again, the benefit of using it 24 hours a day, 7 days a week, 365 days a year. And so that you don't have the maintenance aspect of it as we did with the original versions of the camera. And there's a cost, obviously, to servicing those coolers, taking them out of service every year. Now you can go 2 or 3 years before you would have to take that out of service for a couple of weeks to get the cooler basically recharged with the coolant that we use inside there. The other thing that's important down at the bottom, as I mentioned, is size, weight, and power. So on the one version we provide to the for drone applications, every gram counts because it obviously relates to flight time. So we have a product that weighs approximately 541 grams, so super lightweight, extremely small, fits in the palm of your hand. And so you'll see then that you can actually integrate this with other types of sensors. So in many cases, you'll see that the OGI camera is used for detection and for visualization, and then you'll combine that with a couple of other sensor technologies for quantification. So the first is TD loss lasers, tunable diode lasers. And there's a number of different companies down on the show floor that have variations of that. And those can be integrated in conjunction so it can give you basically a concentration measurement. And then the other way of doing it is to use a sniffer. And so in that case, you'll see some examples where the sniffer may be placed on the top of the drone and the OGI camera is on the bottom of that. So again, you can get both the detection, visualization, and quantification. So you can cover a super large area very quickly, very efficiently. And there's a couple of companies down there that are doing now drone in a box. And you'll see that those companies using the system can place strategically their charging stations so that you can do things like linear assets very economically and be able to just basically launch the drone and go from box to box. I call it hopscotching, okay? Another thing that we've recently done is using longer focal length lenses. This is an example where we were flying from 700 to about 1,200 feet AGL. That's the first part of the image there, from a fixed wing aircraft. I have not seen any other companies really doing something like this with an OGI camera. And we were able to fly linear assets again, like pipelines. We did staged leaks and actual leaks, and being able to do that with a longer focal length lens so that you can fly higher basically, that enables them to be able to visualize these pipeline leaks. So again, these are mostly crude systems, but as you can again see on the show floor, you're going to see a lot of examples of VTOLs, and I believe that that's going to be a very strong potential technology for being able to do that as well. They may not need to fly at those kinds of heights, but and certainly they probably can't right now. But eventually, I see them as a really good, viable alternative to being able to be used versus maybe a crude type of system. So here's some common integrations that I've kind of talked about. Obviously, the first one is a variety of different multi-rotor drones. In the image right now, a classic example that has been around for a long time is, again, crude or helicopter-based solutions. Those are generally in very nice, stabilized gimbals. Again, they can fly for long durations of time and cover enormous areas and do it very efficiently. One of our technology partners you'll see down there is MFE Inspection Solutions. They have the Ventus OGI camera integrated onto the Spot quadruped. And what's unique about that is you can also quickly disassemble the camera from Spot, and it turns into a handheld portable camera that's super lightweight, under 3 pounds, I believe. Beautiful screen, easy to be able to manipulate. And then, as some of the other people have been talking about continuous monitoring, many different companies, our technology partners, are using these for mounting, again, on skids, poles, or masts for doing continuous monitoring. There's a couple of significant programs out there where they're using the camera, and by optically, they're doing the quantification. And then others are being able to, again, combine it with other technologies to do the quantification and alarming if a leak, in fact, occurs. These are just some of the attributes of the camera. I won't really go into that. We can talk about that later. Just some outlines here, the main key points of the product. Just wanted to wrap it up with a few more images. This is, again, this gas enhancement mode, which is very, very popular with all of our users. Again, even for people who have never really worked with an optical gas imaging camera, it makes it very easy to learn and be able to easily identify where the leak is coming from. Okay. And some of the things I just wanted to wrap up with here is where I have some ideas as far as where I think the technology is going. We've been talking about some of the EPA and Quad OB and Quad OC and what that may look like. And I still think there's going to continue to be a lot of combination of the integration of different technologies. I don't think one technology is going to be the winner. I think it's going to be the integration of many technologies that's going to solve the bigger problem. There's going to be more and more platforms, as other speakers have talked about, where the products are going to be disseminated and how they're going to be used. And to me, one of the most important things, especially with the Quad OB and C and the Appendix K, is really going to be the workflow part of it. It's going to be the back end side. And that's going to be really important to get the results that we find in the field and to be able to deliver that to create action. And I think that is going to be where you're going to see a lot of growth on the back end with software, AI, edge processing, those types of things. And integration certainly into how people actually use the systems in their PLCs, digital control systems, SCADA, et cetera. Another thing I think that's coming, I think there's a number of companies that are working with our product to get it class rated. I think that is going to be important from an aerial standpoint in confined space areas and in class rated areas. I think you will see the advent of that. We'll continue to move to higher resolution, HD. People just like we watch our televisions, we want more resolution, and everybody wants that, especially for the fixed mounted, because more pixels on target means higher probability of detection to be able to see smaller leaks at further distances with better optics. Those are the things that are going to happen. And then new, longer focal length lenses. That's really not an issue. It's just everybody has been using 25 and 50 millimeter focal length lenses, but I think there will be applications, especially on persistent condition monitoring type applications, where people are going to want to use longer focal length lenses to make a 360 degree, for instance, panoramic type of system. And then like a freight train, video analytics and AI is coming. We just did a shootout this last week, and I think there were 7 different AI companies, figuring out how to apply our sensor technology and how each one of them can do something a little bit different. And I think that's going to create better certainty in the technology as well. So over the last, I put this comment in here. If anybody, I don't know if anybody in the audience knows me, but I helped develop the very first OGI camera back in 1999 for a company that was based in Central Texas. And we've seen a lot of changes in the technology. It took us about 10 years to even get it really adopted. And once it started to get some teeth with being regulated, and then over the last 10 years, as the mindset about all of this has changed, I think it is important, and I think everybody is on board, from regulators to industry, that they want to move forward and they want to try to achieve net zero by 2050. And I think optical gas imaging can be a big part of that. And we hope all of you out there will certainly consider our technology. So appreciate it. Any questions?
Josh with Green Path here. I may have missed in the presentation. My apology if it's already there. Is the camera spectrally tuned for one species or multiple species, like between 3.2 micrometer and 3.7? Are you doing multiple absorption bandwidths, like methane,
No.
propane, butane?
So the cold filter inside the optical gas in the mid-wave camera goes from 3.2 to 3.4. So what happens is there's about 23 hydrocarbon gases that all emit or absorb in that wavelength region. So this camera by itself does not discriminate or speciate the individual gases. They all look exactly the same to the camera. Now, there is an organization that has figured out how to put an optic in front of basically that actually scans, and they freeze it and they stop it at individual wavelengths. And so you can tune it in order to be able to speciate the individual gases. That's unique. Okay, so there's only one company that I know that's doing that. I believe that's patented, and so you can come down to the booth if you want to ask me any more questions about that. But as an individual camera, it cannot discriminate by itself. They all look the same. So there's two elements of this application again. It's number one is the narrow bandpass cold filter. That actually images the gas. But the other thing that's super important is that you have to be able to have a delta T. You have to have at least, on most of the cameras, it's between about 5 degrees or 3 degrees centigrade, somewhere in there. So whenever you're trying to do this, if you have an equilibrium state between the gas and the background, it's very, very difficult. So that's one of the huge benefits of using a drone, because you get this perspective of looking down or forward down. You always have a good background, like around the facilities, cement, rock, dirt, those sort of things, and you get a lot of contrast no matter what time of the year. And it doesn't matter, you can always have contrast on the cold side as well. So you can have a cold background, and now the gas, instead of appearing dark like it did in all of these videos, will be just the opposite. It will appear to be white. So as long as you get the crossover point between a little bit of delta T, then you'll always be able to visualize the gas. Any other questions?
Okay, great.
All
Thank
right.
you, Jeff.
Thank you all.